In this lesson, we'll learn a technique for creating a stretchy IK limb. Now you might find with stretchy limbs that scale is used to make sure that the chain will always stretch proportionally. However, instead of using scale, we're going to work with translation. That way we get a cleaner stretch. It's just like the flexi line. When we start to pull or compress it, we don't have any skewing issues that we would get with scale. Alright, so we need to go ahead and think about our equation so that this will work correctly. We will be using a condition statement so that when our chain reaches its max length, that's when our stretch will work. If we don't use that condition statement, we'll notice that the leg will also be able to compress and we'll lose our knee bend. Alright, so we don't want that to happen. Now the core of the equation will be as follows. We will find our max length, and then we'll need to divide the length of the thigh and the length of the shin by that max length. We need to also make sure that the global node will be influencing that result. And then we need to take all of that and multiply it by the change of our distance. So that max nodes, when we start to pull that chain around, when it reaches that certain distance, it should always start to stretch. And then once we start to get back to the normal length, we'll get our knee bend back. Now after all of that, remember we have frozen the transforms on our bones here. So we're going to be working with zero value. So we just need to make sure that by the end of this, we set up our expression in a way where Max will take a look at that zero value and use it to make sure that nothing shifts when we evaluate our expression. So let's go ahead and start building this. We'll start by first making sure that we unfreeze the length of our IK chains now. So we'll unfreeze the thigh and the shin. Let's go ahead and grab our bone tools. Alright, so there's the thigh on the left side. We'll go ahead and take care of the shin next. So once we've unfrozen the length there, we'll do the same thing on the right side. Alright, now we can go ahead and create exposed nodes for the right and left legs. Let's go ahead and grab our create panel and we'll use our exposed TM node. Let's add that, and underneath the modify panel we'll go ahead and take a look at its display properties. I'll leave this set to cross, but let's go ahead and bring the size down to about 5. And now we'll go ahead and align this to our left thigh. That's position and orientation. We're good to go here. Let's make sure that this is added to our hidden layer. And we'll go ahead and give this a name. So we're using this to acquire the distance of our chain so we can drive our stretch. Let's go ahead and name this distance underscore L underscore leg, and we'll add IK01. Alright, we're ready to clone this object. Control V. Let's go ahead and rename it from here. That's distance R leg IK01. And we'll go ahead and Alt-A align this to our right thigh. Now to make sure that both of these follow, we can simply have them linked to our pelvis control. Alright, great. So now we're ready to expose the nodes we'll need to find our distance. Now very important, we want to make sure not to expose anything that's directly tied to the chain that is going to stretch. Otherwise we'll run into a circular dependency issue. So instead we can go ahead and find objects that will work in a very similar way. So the objects we'll use will be our FK thigh control, since it's always going to stay right here at the thigh. And then to find the object that's going to change in length, we could always tie in our IK goal object, since when we start to move the IK control, that goal will always follow. So now that we know that, with the exposed node selected on the left side, let's go ahead and move to our modify panel and let's go ahead and start to plug in that information. We'll uncheck parent. Let's go ahead and expose the FK thigh control. We'll also grab the IK goal. So we'll go ahead and use that as our second object. And take a look, we now have the distance we need. When we go ahead and scroll down, here's the distance, but this is not our max distance. If we do not use the max distance, what's going to happen is when we start to pull the leg, it's actually going to keep this bend we have here. So we want to make sure that it stretches, and that's the value we want to use. So this is very simple to find. If we were to go ahead and grab our IK control and start to pull this, I'll just go ahead and drag this down just a little bit. Now, when we go back to our expose node, we'll see the value we can work with. So that's about 31.57. All right, great. So now that we have that in mind, we can always take our IK control, right-click, or alt-right-click that is, and use transform to 0 to bring it back. Also, feel free to go to your center of gravity and enable IK for both the right and left legs. Now, before we start to set up our expression, expose node on the right side, again, we know what to expose. Let's go ahead and first turn off parent on this object. We'll expose the right leg's FK thigh control. We'll also expose its IK goal. Alrighty, so now we're ready to start working on our expression. We will be using the IK nubs, so I'd highly recommend that we go ahead and select those and freeze their transforms now, just to zero out those values. So the expression is going to be tied to the IK shin and the IK nub. All right, let's go ahead and get started by working on the left side, the shin. We'll move over to our motion panel, and we'll need to assign our float expression to the axis that's going to pull, and that's going to be the x-axis. We know that by making sure our move tool is set to parent mode. We can see that the x is pointed in the pull axis. All right, so let's go ahead and select the 0 position x and assign our float expression. All right, we'll create our variables now. So the first one will be global. We know we need to tie in our global scale. And the next will be distance. Let's go ahead and choose create. And we know that here we'll need to go ahead and plug in the distance channel of our expose node. So with that selected, let's go ahead and assign our controller. We will expand the global node. Remember that distance node was parented underneath the animation control for the pelvis, so we'll need to also expand the center of gravity. There's the pelvis. Let's expand that. And here's the distance node. So that's the one for the left leg we'll need. Expand that, object, and grab distance. All right, great. Let's go to the global variable. And we'll go ahead and find our global control and get to its transform scale y. All right, we're now ready to start building our expression. So remember, we need to go ahead and take the length of our thigh, and then we need to divide that by our max distance. So to find the length of the thigh, it's actually really simple. With the shin selected, if we were to take a look at the x-axis, we have the length of the thigh, because this is the offset that the shin has from its parent, which is the thigh bone. So that distance then is 15.506. All right, so let's go ahead and copy this value. We'll add that to our expression. And we want to divide this by our max length, which we know to be 31.57. And then we'll want to multiply by our global scale. Let's go ahead and concatenate this because we need to add a little bit more here. So once we have this, remember we need to make sure that the change in our distance will influence this expression. So we'll go ahead and take the result here, and we'll want to multiply by our distance. Now remember that this 15.506, this is, yes, the distance of the thigh. However, remember we have frozen transforms on that bone. So its actual x value is 0. So we need to go ahead and make sure that by the end of this, all of this we see here will equal to 0. So here's what we'll do. We'll simply go ahead and concatenate from distance to the first part of the code. So we'll add a few more parentheses here. And now we want to subtract by this value. So we'll go ahead and copy the 15.506, and that's what we subtract by, and now this will equal a value of 0. All right, now before we're finished with this, remember we're using our condition statement because we don't want this to just start pulling the leg, because we'll notice that we'll get a compression as well because there's nothing to tell the code to stop the squash and stretch. We just want to make sure that this stretches the chain so we don't lose our knee bend. So here's what we'll do. Right before our parentheses, we'll type in as follows. That's going to be if, and we'll concatenate again. So let's go ahead and add another group of parentheses. And right after the first parentheses, that's going to be distance. And if that distance is greater than or equal to our max distance, which is 31.57, so let's go ahead and add that, 31.57, and then we'll also need to multiply by our global variable, the global scale, so we'll go ahead and add that. It's going to be times global. So if this is true, let's go ahead and add a comma right after global. We want this to be evaluated. And just to be on the safe side, I'm actually going to concatenate the max distance, 31.57, and the global. We're going to concatenate those just to make sure that max will read this properly. That's going to be 15 divided by this max distance. All right, great. So, again, once this is true, this will happen. If this is not true, let's go ahead and go to the very end of our true statement. We'll add another comma, and we'll go ahead and put in a value of 0, which is the value of our x-axis. So if this is not true, we want to make sure that that value will equal 0 so we can get our knee bend. All right, so we can always go ahead and copy this information just to speed up the time it takes to finish our stretchy rig. We'll need to add this to our ankle nub. All right, so with all of this now added to our expression, we can go ahead and evaluate. Notice when we do, the leg is not going to shift. If you notice shifting, that's simply because we use the right values, or we haven't concatenated the 31.57 multiplied by our global, what we need to make sure that the stretch works right here in the true statement. So we just need to make sure that all of this has been typed in correctly. So once this is evaluated, we can go ahead and do the same thing now for our ankle, and then we'll test this out. So the ankle should be faster to build. Remember, we need to find the length now of our shin, and we know that to be 15.915. So that's the value we'll need to use in the expression. So with the ankle selected, let's go ahead and go back to our motion panel. We'll expand the FK sub control. There's the position, 0 position X. Let's go ahead and assign our float expression. All right, let's go ahead and paste our expression in. Let's now go ahead and take our length of the shin, go ahead and copy that, and use that instead of the 15.506. So we'll just simply go ahead and paste that in. We'll need to use that same value at the end of the true statement. Beautiful. So from there, we're ready to create our variables. We'll go ahead and create the global variable, and we'll create one for the distance. We're just about ready to test this out. Let's go ahead and choose create. And now we'll go ahead and assign these. So we'll go ahead and find the distance. There it is. And our global scale. There it is. And we're ready to evaluate this. We'll check and make sure nothing shifts when we do. Beautiful. So let's go ahead and see what we have just created. We'll go ahead and close this out. Let's go ahead and grab the control object, the IK control, and start to pull. And notice there's our stretch. And again, we're stretching along our translate x-axis. So that means is that we're going to get a really clean pull here. There's no scaling involved. How exciting is that? That's really cool. This is really coming together. I'll go ahead and Alt right click to use transform to 0 to bring our control back. So we now know what we need to do on the right side because it's going to be the exact same steps, the exact same values. So I'll go ahead and leave the right side up to you. I'll take care of that in between lessons, and in the next lesson, we're going to finish our stretchy system by making sure we can turn that on and off.